Today we are going to solve the problem maximum Manhattan distance after k changes. In this, we are given a string consisting of the 4 characters N, S, E, W. Now, if it is N, all these 4 directions are representing a direction in which we move by 1 unit in all of them. Initially, we are at the origin. We can change at most k characters. At most here is highlighted so that we can focus that at most if it is given 1, as in this example, it means 0 time or 1 time. And we can change this to any of the 4 directions. It is our choice. Now choice has to be made in such a way that we choose the maximum Manhattan distance. What is this Manhattan distance? For example, if we are having this grid east, west, north and south. This is the origin where we are initially, and if we are here and if this point is 3, 4, then 3 minus 0 and 4 minus 0, their modulus sum is represented as Manhattan distance. From the origin, we concluded that can be achieved at any time while performing the movements in order. What these two highlighted words mean are at any time means whether we are at W, if we achieve this maximum Manhattan distance at W, we will stop here. If at S we receive the maximum one, then we stop here. So at any time while doing this thing, this changing process, and in order means we will be traversing from 0 index, then 1, then 2 and then 3. If we take first initial point as 0, 0 and if we move in the north direction plus the east direction or the west direction and the south direction, then our value will increase at this point or at this point. The maximum Manhattan distance increases, but if we go in the opposite directions, for example in north and south and in east and west, then it will cancel out. It will lead to -2 and this will lead to +2 in the Manhattan distance. Now to understand this +2 -2 exactly, we will go through this example. We are given N, W, S and then E. Now while traversing in this from 0, 0, we will go towards the north by 1 unit. So we have reached here. Now we will go towards the west, then south and then east. Now here the maximum will come out to be 2. See how? And here we are having 0x, 0y. Here when we move towards the left, x decreases by 1, that is it becomes -1, 0. Okay, then here the sum will be what? It will be 1. When we come here, this is what it is. We are moving towards south. We are decreasing the y index, -1, -1. When we take its absolute value, it is 2. And when we come here, it is again what? It becomes what? It does not become 0, 0. Remember that. It becomes what? We increase the x-axis one, that is it becomes 0, -1. It does not have to do anything with the coordinates. We are supposed to just remember this 1 unit thing in the particular direction, and here the absolute sum will be 1. So maximum that went here was 2. But the answer is 3. Why? Because we are allowed to make at most k changes here. Now how can we make this k change? Instead of going towards the south, because I said north and south are the two cancelling directions, which are the conflicting pairs. So instead of taking the south, after this north, we observe that we don't need to take the south. Instead, we can change it to what? We can change it to north only. So this will increase how? From this point, we don't go to this point. So 1 here and 1 here. So it leads to a distance of +2, incrementing the maximum Manhattan distance. So what it will look like? First we go towards north, we reach here, then west, then again north, and then we could have changed this east also, because after west, east will be also after this west, east will be a conflicting thing, but we are allowed to change at most 1 only, which we utilized it here. Instead of south we took north, so we will have to use east here only. So at this point, originally we were at 0, 0. Now when we move 1 unit towards the y-axis, so it will be 0, 1. So sum will be 1. Sum here will be 1. At this point, we move towards the west. West means we decrement x minus 1, comma 1. It will lead to 2. Now we move towards north. We increase the y index, that is 2. It becomes 2, it will add up to 3. Now we move towards the right, that is x will increase, that is 0, comma 2. It is 2. So the maximum Manhattan distance here comes out to be 3, which is our correct answer. So in this way, we just cancel out the opposite pairs. Now, looking at this example 2. First, we are allowed to change k times. See, first we go towards north. Here it was 0, 0. Now here it becomes what? 0, comma 1. Then next is what? After north, it is south, which is a conflicting pair as we just read and understood here. So instead of south, we make it north. So it becomes north, north. And k reduces to 2 here. Okay, we have made one change. So we move again towards the north, that is 0, comma 2. Here it comes out to be 1. Here it comes out to be 2, the Manhattan distance. Okay, you can calculate it. 0 minus 0 plus, see, don't get confused. 0 minus 0, doesn't matter you take this 0 or this 0, because that is the modulus sum. Plus 2 minus 0 or 0 minus 2, you can do anything, it's a modulus, so 2 will come. In this way, the 2 is coming. Okay, don't get confused. Then we come to a west. From here, we go towards the west, that is, it becomes minus 1, comma 2. So distance will be 3. Now, after west, we go to west again. That is, it becomes, we are at this point, so it becomes what? Minus 2, comma 2. It still increases, it becomes 4. Now, we have traveled both of these W. Now, east is a contradicting pair. That is a conflicting pair. So we reduce it. Reduce the value of k and change it. K becomes what? 1. So instead of east, we again go to west. That is minus 3. I'm just writing the coordinates. Minus 3, comma 2. That sums up to 5. Now the next one is again west. It goes to minus 4, comma 2, which adds up to 6. Until now, 6 is the maximum one, and 6 here is the output. You can see the explanation which is given. So in this way, we get the maximum Manhattan distance. Now talking about the code, it is very easy to convert it into code. Initially, we are given a function named max distance. It returns a data type of int. We are given a string s, and the k times changes can be done. Initially, we take maximum distance and current distance as 0, and we take the distance traveled without the conflicting pairs. We are not conflicting, we are just declaring it, we are not initializing it. Here we take east, west, north and south initially to be 0, the count of these characters in the string. This for loop is very simple. What to focus here is, we are normally traversing here. If the character is north, north one is incrementing, south for south incrementing, and for east we increment east, and for west we increment west. Why we take west as for sure in the else part? Because we are given, see, in the constraints we were given s consists of only these things. So there is no issue for us. We can safely take it in the else part. Now, what is this else? L stands for the total moves iterated till now. That is the total length. That is the string traveled. Now, minimum pairs is the conflicting pairs here. We said north and south clash each other and east and west clash with each other. They reduce the Manhattan distance by minus 2. So, we consider it here. Why we take min? Because if it is 2, comma 3 for north and south, north is 2 times and south is 3 times in the string, then these two of the south directions and 2 of the north directions will be conflicting. So, we take the minimum one. Now, in this if thing, understand this if else part. Initially, in the first example, I had what? K was 1. K was 1. So, if my 1 is greater than or equal to the minimum pairs, if the allowed changes, if the changes, I'm writing in short, if the changes allowed is greater than the conflicting ones, then we can change all the conflicting pairs. If I'm right? If the changes allowed in the question are greater than or equal to the conflicting pairs, then we can change all those and achieve the maximum Manhattan distance. So it concludes to the total iterations that I make. So it is equal to L. current distance will be equal to L. Else, if the changes allowed are less and the conflicting pairs are more, then first we calculate base distance without non-conflicting pair. See, this is the total iteration L, and we are having number of minimum pairs, that are the conflicting pairs, and each decreases it by -2. So we multiply each conflicting pair by -2 and subtract it from the total distance iterated. So this gives us the distance that we can travel without the conflicting pairs. Then we use this distance and add it the current k that we are having. If k is 1, that is, it becomes 2 into 1. We have added the number of changes that will allow us to achieve the maximum Manhattan distance, because one change increases the Manhattan distance by 2. So we multiply the number of changes by 2 and we add to this base distance non-conflicting pairs, because the distance achieved with the distance achieved with the non-conflicting pairs. So this gives us the current distance. And each time after the if else, we calculate the maximum distance, which is the max of current distance and the max distance. And at the end, we return the max distance.